Alright, welcome back. So we proceed finding the inequalities of unshaded regions. Okay, so this one we can look at the first one. We can identify the points. So we can start with this one here, right? This graph here. We can pick the points. So this graph should be simple for you. Okay, that will be our first graph. Okay, so likewise I'm going to use the shaded and the unshaded region. I'm going to have two parts. So we have the shaded equation inequality, and for the unshaded, okay, for the unshaded. So for the shaded regions, let me use a different color. So for the shaded region, this one here, the first one, which is the one I've put in blue, if you want you can just observe here. Okay, remember it is passing at the center, and since it is passing at the center, the inequality describing the shaded region, that is this region, the outer part, is y. All the values there, they are greater than x, right? Yes, so the values there, if you observe, they are greater than or equal to x. They are greater than or equal to x because the line is not breaking, okay, and it is shaded upward. So this is describing the shaded region upward. Now finding the inequality describing the unshaded region, which is downward, it means we will write the opposite of what we have, which will be less than or equal to x. So that is our first inequality. Now the second inequality, we can look at this one here. Okay, this one. So this one we can solve. I think that's the best way. So this one is passing at the point 8, 0, and that's 2, that is 0, 2, right? And 8, okay. I hope you are able to see. So at this point we have 8, 0, and at this point we have 0, 2, and 8, 0. Okay, 8, 0. So we can let this one be our x1 and our y1, right? And this to be our x2 and our y2. Okay, so if this is the case, then we can calculate for the gradient. We know the formula for the gradient, that is y2 minus y1 over x2 minus x1, right? x2 minus x1. So what are we getting when we replace? So we have 0 minus 2, right? Minus 2 over the other one is 8 minus 0, so giving us the value of m to be -1 over 4, right? So the next thing we have to do is to calculate for the value of c by using the general equation for linear equations, which is y is equal to mx, right, plus the constant number. Now this we can choose a pair to use here. Okay, so we can use the first one, which is 0, 2, which means our y will be 2, our x value will be 0. So when we multiply 0 here, okay, x multiplied by the value of the gradient, which is m, which is -1 over 4, we are going to get 0 plus c, giving us the value of c to be 2, right? So our inequality will simply be y, right? That is our inequality will just be y is less than, right? We are saying less than because the shaded region is shaded downward, so all the values downward here, they are less than, isn't it? So this region is describing the shaded region, right? Now remember, the question was describing the unshaded region, right? So if this is the shaded region, then the unshaded inequality, which we should write here, is y, right? Instead of less than, we are going to have greater than, right? So we're going to have greater than negative 1 over 4 x, right, plus our constant number is 2, right? So this is the unshaded region. So this is our second one, right? And this is our, that was our first, and this is our second one. Now we can finally look at the last equation graph, which is we can pick this one here. Sorry about that. Let me use this one. Okay, we can look at the paper one now. So the paper one, we can as well solve it. Just we can choose the point. So the points there, our graph is passing at 5,5, right? And at 8,0, right? At 8,0. So using the formula for the gradient here, so this is the same formula we are applying here for the gradient. We are going to have our y2 is 0 minus our y1 is 5, right, over our y2 is 8 minus our y1 is 5, which will give us the value for the gradient to be, let me just highlight this coordinate there as 1, okay, and this one here as 1 coordinate here, okay, for this down calculations here, okay, and this one here for this down calculation. So the value for the gradient will be negative 5 over 3, positive 3, right? So we can as well calculate for the value of the constant using the general formula here, which is C. So we can choose a pair to use from here. So we can get 5,5 or 8,0, okay? So if we get 8,0, we are going to get, that means the y value is 0, okay? Our gradient is negative 5 over 3, where we have our y value is 8, right, plus C. So solving this one, you see that our value of C will be 40 over 3, right? Okay. So if this is the case, then writing our inequality, okay, first observe here, right, what we have. So our graph is shaded upward, okay, and these values, they are greater than, right, okay, but what we are looking for is the opposite of what has been shaded, because the opposite of what has been shaded is describing one of the inequalities which is describing the unshaded region we are looking for, right? Okay, so writing that one, the inequality describing the shaded region in this case is going to be y is greater than, right? It will be y, right, is greater than, yes, that will be y is greater than negative 5, that's negative 5 over 3, right? X minus, plus 40, okay, over 3, right? So this inequality is describing the shaded region. So the inequality describing the unshaded region will be the opposite of what we have. Okay, so which means the inequality describing the unshaded region is y is less than, right, negative 5 over 3, okay, x plus 40 there over 3. Okay, so let me just highlight this one because we can't write it on top there. I'm going to specify to say this is for describing the shaded region, and this one here is the one describing the unshaded part. Okay, all right, thank you so much for watching. Make sure you subscribe to my YouTube channel, and if you have any question, make sure you post in the WhatsApp group, okay, for the great world online and physical tuition. Right, so see you in the next video.